Hello everyone, and thank you for joining me today. Today we will learn how to add and subtract rational expressions. Adding and subtracting rational expressions is really all about adding fractions. And when we add and subtract fractions, we need a common denominator. So consider this example just to get us warmed up and started today. The idea is to change 7/12 and 8/15 so that they have a common denominator. Well, the least common multiple of 12 and 15 is 60. And to turn 15 into 60, you'd have to multiply by 4. But now to keep this fraction balanced and maintain its original value, we have to multiply the numerator by 4 as well. Similarly here, to change 12 into 60, we'd have to multiply by 5. But again, for the same reasons, we have to multiply the numerator by 5 as well. Now that we have a common denominator, we can combine our numerators, but remember the denominator stays the same. Key takeaways here are that idea of finding a common denominator and combining the fractions by combining the numerators. Well, today we are going to do that with rational expressions that have polynomials in them. And in order to help us do so successfully, we'll have to start by factoring everything that's factorable. This will help us to figure out what our common denominator is. Once our fractions have that common denominator, we'll combine them. And then it may be possible to factor yet again and then simplify. We'll see an example of that. Now let's get our momentum going with a couple examples that already have a common denominator, just so we can practice the combining and simplifying part. So consider this first example where we already have a common denominator. We can go ahead and combine those numerators to get 5 over 5y. But now, like we've seen in previous lessons, we've got a common factor on the top and bottom here that can cancel out, leaving us with 1 over y. In the second example, here again we have a common denominator. So we will combine these fractions. We have a plus a, 11 plus negative 21, giving us this result. Now, it is possible to factor a 2 out of the numerator, and nothing happens as a result, nothing cancels out, but we always need to check, because the one time we don't check is the time where we could have simplified by canceling out common factors. Here's a subtraction example. We already have a common denominator, and we got to slow down and be extra careful with subtraction, because we are subtracting not only 2x but subtracting negative 1, and 3x minus 2x is x, but negative 4 minus negative 1 is really minus 4 plus 1, which gives us a minus 3. Now here's a situation where we can factor the denominator. It's a difference of squares, we should factor it out, and notice that this time we actually do have something that happens as a result. We have common factors on the top and bottom that do cancel out here, and so if we had not factored, our answer would not have been simplified enough. Now it is. Be careful with those subtraction problems. Make sure you are subtracting everything that should be subtracted. Now those are good examples for us to start with and get our momentum going, but they were convenient because they already had common denominators. Let's look at two examples that don't, starting with the left-hand side here. We should start by factoring everything that's factorable, because that will help us to identify what our common denominator is. So x squared minus 4 will be factored accordingly. It's a difference of squares. X plus 2 is not factorable. Now I'm leaving myself a lot of space to create my common denominator. And if you look at what our denominators already have in common, they have x plus 2 in common. But this denominator has x minus 2 and this one doesn't. So let's make these fractions have that common denominator by multiplying by what we need, x minus 2. And recall from our warm-up today, we have to multiply to the numerator and denominator to maintain the original value of this expression. So what do we have now? We've got this common denominator of x plus 2 times x minus 2. I'll go ahead and do my multiplication here so I can simplify if possible. And I can combine the 1 and the minus 12 to give minus 11. But even from here, nothing is factorable moving forward. And so this is it. This is the best we can do by combining those rational expressions. One more example for you over here. We'll factor first. Lots of factoring to be done here. b squared plus 2b minus 8 factors into b plus 4 times b minus 2. leaving myself a lot of room to create that common denominator. B squared minus 16 factors into a difference of squares again, b plus 4, b minus 4. Now if you look at what our denominators already have in common, they have a b plus 4. That's set in place. But this one has a b minus 2 that this one doesn't. This one has a b minus 4 that this one doesn't. So we will make the match by multiplying by what we need. This fraction needs a b minus 4, so we multiply it to the top and bottom. Notice I put parentheses here to remind myself that I need to FOIL up there. Over here, this fraction is missing the b minus 2. So here we go. We've got our common denominator now. You could write these factors in any order. Up top, I'm going to FOIL so that I can combine like terms. And the purpose of this lesson is not to teach foiling from the ground up, and so you can pause and give it a try there and see if you get the same thing I did. And now when we combine like terms, this is what we're left with in our numerator. Like we've talked about previously, we should factor everything factorable just in case we can cancel out some common factors. And that numerator has a common factor of 2 that we can pull out, getting us this far. But even after we do that, I'm looking at the trinomial that's left up top, and it's not factorable any further. There are no factors of 6 that add up to negative 4. And so we don't have any common factors on the top and bottom, which means although this doesn't look like a final answer per se, it's not very simplified. It's not simplifiable. We can't. This is as far as we can go. We have combined our rational expressions according to the process set in place earlier in this lesson. Some examples will already have a common denominator, some like these will not. You've got to factor first so you can see what that common denominator is. Now that we know how to combine rational expressions, we can take this one more step, and we can do one more objective today, and that is to simplify a complex fraction. Complex fraction is a fraction that has fractions in both the top or the bottom, like the example on the screen. Now let me give you the big picture idea, and then we'll finish with an example that has some variables in it. The thought is to take our complex fraction and try to rewrite it so that we have one fraction in the top and one fraction in the bottom. Because as you know, this fraction bar right here represents division. And if we can get that far, then we can turn this into a division problem. And we've learned earlier in this chapter that dividing with fractions, we multiply by the reciprocal. Now in order to get to this stage here, we have to combine these two and these two, and we'll need a common denominator to do so. That common denominator being 3. So what do we have then? We will have a common denominator of 3. We would have 4 over 3 minus 3 over 3. Well, that's 1 over 3. Down here, a common denominator of 6. Let's see, 5 over 6 plus 12 over 6 would be 17 over 6. And once we get to this stage, we can now turn this into a division problem, because remember, that's what this fraction bar represents, division. So we technically have 1/3 divided by 17/6. Well, when we divide with fractions, we multiply by the reciprocal. This gives us 6 over 51, where there's a common factor of 3 in the top and bottom, which we can reduce then down to 2/17. So there's the big picture. Try to get our complex fraction to this stage so we can treat it as a division problem, then as a multiplication problem, and simplify accordingly. So we'll finish with one example that does have a variable in it. This example here. Remember where we're trying to get to this stage, so we can turn this into a division problem, which then becomes a multiplication problem, and we simplify accordingly after that. Well, to get that far, we need common denominators. So looking at the fractions up top, we've got a denominator of 1 and a denominator of x, so common denominator would be x. We would have x over x plus 2 over x. So use that common denominator to combine that to a single fraction. Down below, here again, our common denominator is x. We'll have 4x over x minus 6 over x, so 4x minus 6 over x. We are now at the stage where we have one fraction over another. In other words, one fraction divided by the other. We manage that by multiplying by the reciprocal of the second fraction. And while we're at it, I'm going to factor a 2 out of that 4x minus 6 to help me cancel anything out. Well, we have common factors here and here, and that's about it. So we have x plus 2 left in the numerator, in the denominator 2 times 2x minus 3. So the big picture when simplifying a complex fraction, get to this stage using common denominators, treat that as a division problem, which then becomes a multiplication problem, and simplify accordingly. That's all I have to say today about adding and subtracting rational expressions. Thank you for watching.